Okay, chapter 6 starts with a review of some of the things we already know. So this question is about discrete and continuous, which we did study early on. So in most applications, continuous random variables represent counted data, while discrete random variables represent measured data. So if you remember from early on, it's the other way around, that discrete random variable represents the counted data, and continuous random variables represent the measured data. So this statement that is given is false. This is the correct answer because discrete random variables represent counted while continuous represent measured. So determine discrete or continuous. The number of people in a restaurant that has capacity of 100, discrete or continuous. So the number of people is what we are talking about. A number of anything is a count. So you could have 0 people, 1 people, 2 people, or so on. So it is discrete, and it's this one because that represents the 0, 1, 2, and so on. So note that it like could not be C or D because C, for example, is saying that okay, C is wrong because it's continuous, but D is saying that it's discrete, but yet it's saying the possible values are greater than equal to 0, less than equal to 100. So when you write in this way, you know that you also include all the decimal values that are between 0 and 100, whereas when you are counting something, you're not counting the decimal values, you are only counting the integer values. So that's why it's B and not D. Determine whether the random variable is discrete or continuous. Okay. Is the time it takes for light bulb to burn out. So time is a measurement, so that is continuous. So the random variable is continuous, but the possible values are greater than 0. So for a continuous, you could also have the decimal values. So you could have the time being 0.5 hours or whatever you are measuring, whatever units you are measuring in. So we also studied the probability distribution probabilities, probability distribution properties. If you recall, we will have a discrete probability distribution if the following 2 properties are both satisfied. First is each probability is between 0 and 1 inclusive, and the second is the sum of all probabilities is 1. So let's go back. So this one says each probability is between 0 and 1 inclusive. So note that it's not D because D is not including the 0 and the 1, but the 0 and the 1 could also be probabilities. So A is the right choice. And then the sum of probabilities has to be 1, and that's this one because you know that this is a summation symbol. The peak shopping time is between 8 and 11. Management randomly selects 155 customers and decided to observe their shopping habits. They recorded a number of items. So whatever you are recording or studying or observing, that is the variable. So they recorded number of items of each customer purchased as well as the time. So number of items is a count, so that'd be discrete, whereas the total time you spend, that's a measurement, so that's continuous. So number of items discrete, total time continuous, it's this one. Determine whether it's a probability distribution. So first we check whether these probabilities are between 0 and 1, and yes, they all are between 0 and 1. And the second is they need to add to 1. So let's see what their sum is. 24 plus 18, 42, plus 27, 69, plus 19, 88, plus 1200. So yes, they do add to 1. And so yes, and because the sum of probabilities is 1 and each is between 0 and 1 inclusive. So not that there's nothing wrong in A, but A doesn't say the whole truth. It just says that because each probability is between 0 and 1. That's just one of the two conditions. We need to meet both the conditions, and B says both the conditions. Determine the missing probability. So we just saw that probabilities have to add to 1. So let's add these. So 19 plus 34 is 53 plus 18, 71. So they add to 0.71, but all of these have to add to 1. So the missing has to be 1 minus 0.71, and that will be 0.29.